In this video, we're going to talk about base E. And you guys are used to seeing pi, which is approximately 3.14, but it doesn't stop there, it just goes on forever. So pi is an irrational number. Just like pi, E is also an irrational number. And I'm going to explain how or where E comes from. Let's say Y is equal to quantity 1 plus 1 over x to the x power. Now what we're going to do is we're going to find out what happens to Y as x gets bigger and bigger and bigger. So in other words, we're going to let x go to infinity. We're going to find the limit of y as x approaches infinity of 1 plus quantity 1 plus 1 over x to the x. So when x equals 10, so you could use your calculator and plug in 10 for x. Your y value is going to be about 2.59374. And when x equals 100, your y value will be approximately 2.70481. What about when x equals 1000? Using your calculator, you'll find out that y is equal to 2.71692. Now, what about x equals 10 to the 6th power? Then your y value is going to be 2.71828. So as you use this method, as you increase the value of x, so let's say 10 to the 7th, 10 to the 8th, what you will notice is that this will approach 2.71828182846. And we call this, and then it goes on forever. It doesn't stop. And we call this number right here E. So again, E is a limit as x approaches infinity, as x goes to a big number of quantity 1 plus 1 over x to the x power. As we increase the value of x, this whole thing will approach 2.7182818, so forth. And this number is called E. And E is so valuable because we use it a lot in logarithmic. So what is E squared times e to the 9th? Well, remember, E is just an irrational number. So when you multiply, you just add the exponent, you get e to the 11th. What about 25e to the 13th divided by 5e, 12? When you divide, what's 25 divided by 5? That's 5. When you divide, you subtract exponents, so it's just 5e. What about quantity 2e to the negative 3x to the 5th power? Well, the exponent of 2 is 1. So you could say that this is the same thing as 2 to the 5th e to the negative 15x. Because when you have a, b to the nth power, it's going to be a to the n, b to the n. So 2 to the 5th is 32. And how do you make this negative exponent to positive? Well, it's going to be 32 over e to the 15x. And most of the time, they want you to have an exponent as positive. So they probably prefer this method, even though these two are the same. How does a graph of y equals e to the x look like? Well, if you remember, this is a exponential function because base is a real number, is e. So it's going to look like a typical exponential function with the growth model. So it's going to look something like that, where it's going to go through 0, 1. So domain will be all real numbers. Domain will be negative infinity to infinity, all real numbers. What about the range? The range will be not including 0. So y has to be, the range has to be greater than 0. Any number that are greater than 0. So that's how the y equals e to the x look like. What about y equals e to the negative x? How does this one will look like? This is a exponential decay. So it's going to look like something like that. As x gets bigger, it's going to approach the y value of 0. It will never touch y equals 0, but it will be very close to 0 as x gets bigger. Again, the y-intercept, it will be 0, 1. And the domain, again, domain is all real numbers, negative infinity to infinity. And the range is 0, not including 0, to infinity, meaning that the range has to be a number that's greater than 0. That's the range.